Rahul here again from Myslate, and here we will continue our discussion on derivatives fx equals x power n, and let's try to quickly derive the expression for its derivative. Okay, we'll use the basic formula of f prime x, and we know that it is limit of delta f around x, which is fx plus h minus fx whole divided by h. H is the small interval on x axis around the value x, and we are looking at a very small interval, which means h tends to 0. And we can now substitute this expression here, use the binomial expansion, and try to arrive at a neat formula using some simple algebraic manipulations. And let's look at that here. So we have this, and as I said, x plus h raised to the power n could be expanded to using the binomial formula to this. So here, for example, first term is x raised to the power n, the second term is nc1 times x raised to the power n minus 1 times h, and so on. And now you see that this first term here, x raised to the power n, and this term here, minus x raised to the power n, get cancelled, and all we have is these terms which contain h to the power of at least 1. And therefore we can cancel this h out in the denominator, which with all those h that that appear in the terms on the numerator. And note again that we can cancel these h because h does not take a value 0 anywhere. We are talking of values of h very close to 0 but not equal to 0. And when we do that cancellation, we get this. And from the first term we take h out, so we have nc1 times x raised to the power n minus 1. So that becomes n times x raised to the power n minus 1. And then we have these other terms where we have h appearing as a multiple with some power, which is at least 1. For example, here we had h square, and one h gets cancelled with the denominator, so we are left with h raised to the power 1, and so on. So now it's pretty straightforward. There's no denominator here, so we simply can substitute h equal to 0, and we get a very neat expression for the derivative of x raised to the power n. It happens to be n times x raised to the power n minus 1. So let's look at some applications of this, but before that, note that although we had assumed here that n is a natural number on this power, but this formula holds for any n, not only natural numbers. So that makes it very generic. Look at some examples. So here fx is equal to 3x, and a constant times a function, and the derivative of that would be that constant times the derivative of that function. So this is 3 times the derivative of x, and we know that derivative of x would be 1. Why? Because x it is nx n minus 1. So which means 1 times x raised to the power 1 minus 1. So that becomes 1, right? So therefore f prime x is 3. And you can see that here that this fx is 3x represents this orange curve, and it has a constant slope everywhere, and that is a slope of 3. And that's what we have shown here in this gray curve. This gray curve represents the derivative of this function